Hello all. In this video, I'm going to talk about types of statistics and parameters involved in the statistics. We will understand how each type will differ from one to other and how we can interpret the parameters. Types of statistics are descriptive and inferential statistics. So what is basically descriptive and inferential statistics? So let's understand one by one. So when I say a descriptive statistics, right? So assume that I have a class and I have a students. Say that one of the classroom. So basically, I have some students where I can explain the marks or I can explain the average score of my class. Suppose say in the class maybe 30 students. So I will be able to tell you that, okay, what is the average score that students are getting in my class, right? So because I know that how each and every students are going to get a score in each and every test or any exam, right? So I will be able to read them. I will be able to describe the data of individuals in my class if the size is basically around 30 or sometimes 50 also. So the idea here is that if I'm able to describe the data about anything, right? So in that case, I will be calling that type of process, that type of idea is basically descriptive statistics. So the name itself is says that descriptive, describing. So if you are able to describe any data, right? If you are able to describe any data, then I will be able to call it as a descriptive statistics, right? Without any statistical tools. So that is what is basically descriptive. So it could be a marks, it could be average height of a students, average height of a population, right? Or any length or width, average width of any product, or the quality of products, right? If I'm able to describe the items, if I'm able to describe the data, so then I will be calling it as a descriptive statistics. All right. Then what is the inferential statistics? If my data is too big, if my data is too big to explain, right? Suppose say there are thousands and here I have taken one class. So if somebody tell me that the average marks of your students where you have given a training in your entire career, maybe say that I have given I have taken hundreds of batches, conducted trainings for all those batches, and in each batch, maybe 30 students, right? So there are hundreds of batches, then it is too difficult for me to explain each and every, I would say, batch data. It will be too difficult to explain the average score of my students in all those 100 batches, right? So it is too difficult because I will not be able to understand because I have conducted training a long back. So it is too difficult. So, but at the same time, if I'm able to pick a data from individual batch, suppose say there are 100 batches, 1 to 100 batches, and in each batch has 30 students, right? So it is very difficult to study each and every one in individual batch. So then it is going to be a very difficult to explain anyone that the average score of students in my all batches, right? So what I'm going to do in that case, if I want to explain the average score of students in my all the batches, what I'm going to do, so in the first batch, I'm going to pick some numbers, maybe 3 students. And in the second, I will pick another 3 students. right? Similarly, I will pick three students or four students in each and every batch up to 100, or maybe randomly I will pick maybe three students from first batch, right? Three students from first batch and five students from uh, 10th batch and three students from 15th batch. So like that, I can pick randomly some students' data, right? So I will collect all those data. I will collect all those data and I will find the average, right? I will find the average. And then what I'm going to do, I'm going to tell, suppose say average marks are maybe out of 10, maybe 6.5 from this randomly picked students. These are randomly picked students marks out of what? Out of this 100 batches. So in this case, I will not be having all the students in all the batches. Randomly, I'm picking 3, 5, 4, 5 randomly, maybe first batch, 15th batch, 20th batch. So I will collect some data. Then I will consider only those data and I will take an average 6.5. Then what I can say that, so now I will be able to refer this 6.5 average to the entire batch because it is too difficult to study all the students data. So what I'm going to do, I'm going to pick randomly some students marks and I'm going to get the average of those randomly picked students. So now I'm going to refer this 6.5 and I will be able to tell anyone that okay, 6.5 is the average of my all the batch students, and this is the number which I can say that okay, a 6.5 is the average marks where students have scored in all my batches. So I'm going to refer this to the entire batches, hundreds batches. So this kind of a process, this kind of a statistics is was inferential statistics, right? So what I'm trying to do here, so since I'm unable to do all these things, I picked some data and figured out some number, and I'm going to inference to this entire batches, right? So that is basically the inferential statistics. All right. So if I want to convert this inferential statistics in terms of a population and a sample, so it will be easy for me to explain. Right, they will inferential statistics will and population and sample will go hand by hand. So now what we'll do, I will take one more example to explain what is a population and a sample, then I will come back to the second point. All right, so what we'll do, let me take out this. So let's understand the population and sample. All right, so population can be anything. When I say anything, it could be people, it could be a product, it could be anything, right? So when I say, let's take one example, right? So suppose there is an election, assembly elections. Let's take one of the state. So it can be anything. Say I'm going to take Karnataka. So in Karnataka, we have so many people, 5 point or around 6 crores of a population, right? So all those are basically living in different districts, talukas, right? So all are population, and assembly elections are going on. And you might have seen that as soon as the voting is done, right? When people cast their votes, and after that evening, you might have seen in the news channels like exit poll, right? So how TV channels are going to come up with some numbers in the exit poll? What they do, they will predict that okay, BJP is winning maybe 130 seats, Congress is winning maybe 100 seats, JDS winning maybe some seats, right? So others are winning some seats. So I'm just taking some numbers here, right? There's no any kind of a thing here. So I'm just picking some numbers. So how they will be able to come up with these numbers? One channel will come up with this number and another channel number will change. Maybe they will say 100 here, maybe a 95 here, here a 20 here, a 10, and different channels will come up with different numbers. How will they be able to come up with this? Because they are not going to study this entire population, right? So how they will not be able to, it's impossible to reach each and every person in the any state. Take any state, Karnataka, Tamil Nadu, UP, MP, Rajasthan, whatever it is, right? It is impossible to reach each and everyone and take their opinion. So rather what they will do, right now what I'm going to call, this is basically a population. Population is basically entire data, entire items, or entire population, right? So population can be anything. So since I'm not able to explain this entire population opinion, right? I'm not able to explain. So what I'm going to do, I'm going to start picking data randomly, right? In a different district or a talukas, right? I will pick some 50 people here, 50 people here, 100 people here, 200 people here, 50 here, 200 here, 300 here. So like that, I will start collecting the data randomly from different parts of any state, right? So I will take the opinion of those people, right? Not only from one place. So I'm just assume that I'm going from city A to city B. On the way, we'll find so many places, villages, talukas, or anything, right? So there I will pick some 10 people. Here I will pick 20 people. Here I will pick 30, and here are 5, or here 100. So one place to another place. From B to I will travel to another city C. Here I will start picking some of the data, right? So I will take a opinion from different people in between. So I will collect all these data, and this data is basically nothing but a sample. This is a population, and randomly I'm picking some data here. When I say data, people's opinion, right? Picking randomly some people and taking their opinion, and they will collect the sample, and their opinion definitely I will be able to describe, because when I say sample, so that sample will be very less. So it is easy to explain. It is able to, I will be able to describe in a very better way. So I will take this sample and take their opinion, and now I will start making a prediction, right? I will start making a prediction. Okay, how many people maybe I have collected overall out of 5 lakh, maybe I have collect out of 5 crore, I might have collected say that 10 lakh, or maybe 1 lakh. It depends. It depends how you are going to uh, collect the sample. It all depends upon a different criteria and things like that. So that is why you see a different numbers in different channel. It all depends upon how many samples they have collected and things like that. So since they have collected samples, and they will take their opinion, and based on their opinion, how many are going to XYZ party, and how many are going to ABC party, and how many are going to some other party, right? So based on that, what they will do, they will come up with some number, right? Then what they are going to do, they will tell them these numbers are belongs to this entire population. So this is something we call it as a inferential stats. I'm inferencing. I'm referring this sample result to this entire population. It is simply because I am unable to predict, I am unable to reach all the population, I am unable to read all population mind, or unable to take opinion from all the people in any particular state. So for that, I have taken some sample, and I have taken opinion from their the sample data, and I have figured out some number, and I'm referring that data belongs to a population, that opinion belongs to the a population opinion. That opinion is a population opinion. Here I'm not going to call it as a sample randomly picked people opinion. I'm going to refer that I'm inferencing that this opinion is basically a population opinion. That is a inferential statistics. They both go hand by hand, descriptive inferential and population and sample. So whenever I'm going to study this data, this will become what? Descriptive statistics. I find the data, then I'm going to refer this, that is going to inferential. It's nothing but inferential statistics, right? You can take any example, not only the politics related. So you are manufacturing a product, say that a TV. You are manufacturing a TV, and mass production. In one batch, you may have manufactured 200 TVs, and in the first batch, and in the second batch, you have manufactured another 200 TVs. So daily, assume that you have manufactured around 10,000 of TVs, right? And in the second day, maybe another 10,000. So what you have done, you have manufactured totally, say that 1 lakh TVs. So is it that company ask a quality engineer to validate or check the quality of all 1,000 or sorry 1 lakh TVs? No, they don't do this because it's time consuming. They have to hire many people to do the quality check of all the 1 lakh, right? This is not about the total. It is about only maybe 10 days, 10 days TV quality, right? So now think about a monthly production and yearly production, how many engineers they have to hire, right? So what they do, so in the first batch, they will pick randomly 10 TV. In the second batch, they will pick another 15. And in the third batch, they will pick another 20. In the next batch, maybe 12. So randomly, they are going to pick some TVs and those TVs will be validated or the quality will be checked only those set of samples. And if all those samples are looking good, if all the quality in all this TV looks good, then they will say that entire batch is good, entire batch is good, all basically all 1 lakh TV qualities are good. That is how they are going to do the quality control. So it is not necessary that each and every TV needs to be checked. Each and every TV needs to be validated. So this they can take some samples and validate it, and they can tell that okay, if all are good, then yes, all these TVs are good. Then they'll just pick, uh, stick that sticker right to in each and every on each and every TV. So this is basically population, and here in this case I can call it as a population. And the data which I have picked randomly in each and every batch, this is basically a sample, right? And in the sample, I will be able to describe. That is nothing but a descriptive statistics. And after describing, I'm going to refer and I'm going to infer to this entire population. That is process is basically what is a inferential statistics. All right. So that is the idea behind descriptive and inferential population and sample. Hope things are clear here. All right. Now let's come back to this point, and you may be wondering that where the statistics is being used. Right? Statistics is being used in many industries. So I have listed very few here. So it could be weather forecasting, giving insurance, a stock market, right? As you can see here, so in all the use cases, behind the scene, a statistics is working, right? So yes, and weather forecasting will have different criteria to forecast the weather. Insurance also. like they will study the past data, who has prepaid the premium and things like that. So these are the use cases, I would say. I'm not going individually in each and every use case. So I'm just trying to give the basically the idea behind where and all the statistics being used. All right. Not most of all the 99% of your machine learning or anything, right? Any problem you're going to solve in the machine learning, statistics being used. All right. Yes. These are the use cases in where statistics being used. Let's move on and understand some more methods here. Statistics is all about understanding the concept here, right? Understanding the concept. The programmatic or the equation related things will be handled in the machine learning. All right. So in the statistics class is basically understanding how things will work. What is the concept behind each term? All right. So now let's understand some of the parameters here. So a mean, a median, and more. We'll understand one by one in a few minutes. So if I talk about a parameters, how to interpret the basically how to represent mean, median, or a standard deviation, things like that, let's understand. So we have understood what is a sample. We have understood what is population. If I take a mean of a sample, and how will I represent? It's basically X bar. And what is mean by the way? Let's understand that one. Then we'll come back to this. And later again we do some kind of a practical and see that how things will work. All right. So when I say mean, mean is basically the average. Very simple term. There is nothing complex in it. Average. Suppose say in the first test, and let's say first and second and third test. These are the third test, and these are the marks. Any marks, maths, science, or anything. In the first test, you have taken out of 25, maybe 20. In the second test, you have taken 19. And in the third test, you might have taken 24. Right? So the final score is basically what? The average of all these three. So whenever you attend them, whenever you get your certificate or mark sheet, right? So in that you will be seeing that unit test scores separate and the main exam marks separate. So out of 25, so how they are going to give? It is basically the average of this data. The average is basically 20 plus 19 plus 24, 20, 19, 24 divided by how many times? 1, 2, and 3. Right? So whatever the data you are going to get, that is basically the average or mean. That is simply average of all your data. All right. So if 4 items, yes, 4 plus some more, one more number, whatever it is, then it is divided by 4. Or if you have a fourth test, yeah, I will get some data here, some maybe 25. So here it is a 25. In that case, it is going to be the fourth one. Then it is going to be like this. That is simply nothing but mean. All right. Then what is a median? Median is simply nothing but the center data. Suppose if I have a 2, 4, 5, 8, 9, 10, or and one more say 30. So what is the median here? It's basically how many data points we have. 1, 2, 3, 4, 5, 6, 7. Right? So median is going to be 8. The center data. So that is going to be my median. So what if I have one more data? So 30 and here I have a 32. So in that case, I have a even numbers here, even data points, 1, 2, 3, 4, 5, 6, 7, 8. In that case, which one is going to be my median? So in this situation, what median how median is going to work? It is going to consider 8, this data, and 9. It will take these two and add, and it will divide by 2. Two data points, 1 and 2, right? So 8, 6, 17 divided by 2, and it is going to be 8.5. 8.5 is basically the median, right? So that's how median will be calculated. And the last one is mode. What is mode? Mode is suppose say that I have a numbers 2, 5, 6, 2, 7, 8, and 2, something like this, right? Mode is basically if any one number or maybe two numbers possible, if any number is occurring more number of times, then that number will be called as a mode. It is basically a frequency. So in this case, so which number is occurring more number of times, right? 2 is occurring more number of times, 1 time, 2 time, and 3 time. So the mode is basically 2. What if I have one more 8 here? So 8 is occurring 2 times, then that will not be considered as mode. The number which is occurring highest in the given list, in the given data set, that number is basically a mode. All right. So these are the basics for the parameters in the statistics: mean, median, and mode. All right. We have talked about mean, median, and mode. All right. Now let's understand. Yeah, as I said, a mean. If I'm going to take a mean of a sample data, I'm going to represent it as a X bar. If I'm taking a mean of an entire population, we have understood what is population, then I'm going to represent it as a mu. All right. If most of the time we refer this, again, depending upon the situations, these symbols, these terms will change. This presentation, this representation will change, right? But most of the time we refer this one. Whenever we see bar, maybe it's a X bar or a Y bar, whatever the name, whatever the symbol, whatever the letter here. So if you see this bar, it is basically a sample mean or a mean. All right. And what is a standard deviation here? We'll talk about a standard deviation. So standard deviation is basically, so if I have a, we know this mean, right? So mean, and we got some number here, suppose say 5. Anything, for any reason, just assume that we got a mean equal to 5. And standard deviation is basically tells that how much data is deviated from this mean, right? Suppose say there is a number 7, right? There is a number 7. Then if I compare this with a mean, how much data is deviated? So I can say that, yeah, 2. Now I'm just giving an idea here, rough idea. So basically the idea is that how much data is deviated from this mean, right? So that is nothing but standard deviation. How much data is deviated, right? So then I can say that how do I represent? It's a small s for the sample. If it is a population, I'm going to represent as a sigma. Right? I hope you are all aware about this symbol sigma. So this is how I will be able to present it. Right? That is about a standard deviation. And variance. Variance is simply a square of this standard deviation. Right? S square and sigma square is the variance. So when I say variance, basically I have so many data here. Suppose say age, right? I'm going to study all this data and I'm going to find what is the variance. So since I have got the standard deviation, and how I'm going to find the variance, I'm just going to square it. Very simple. Standard deviation, you can kind of assume that it's a tolerance, plus or minus. Right? If I ask you that how much India is going to score against Australia, then some of you may say that, okay, against Australia in a T20. So you may say that maybe 170, then you will add plus or minus 10, right? So this 10 is basically what? Standard deviation. So it's just a rough idea how to interpret this. So it could be 160 or it could be 180. And in between you have 170. This is a tolerance you are giving basically. So that's how we can interpret this standard deviation. All right. We have a simple formula for finding a standard deviation and a variance. We don't need to do any kind of for the mean also, median also, mode also. We just need to use the name. That's all. All right. So yeah, let's understand. Let's execute some of the code here and see how things will work. All right. So here, what I'm going to do, I have some data here, as you can see, 10, 20, 30, some numbers. And what I'm going to do, I'm going to use a mean, median, and mode, and we'll find the numbers. So if I want to use a pure statistics, then I'm going to import a statistics as a ST here. Going forward, I will use only ST. So what I will do, let's not get into this pandas. What I will do, I will just use only statistics, right? So ST I'm going to use, and I'm referring ST. Then I'm saying dot mean. That's all. ST dot mean. Mean of what? Where is the data? Yes, here is the data. That data I'm going to refer here. I'm just printing it. X has my all data. I'm giving this data over here, and I'm just saying st dot mean. St is nothing but the statistics, and mean is the method that we use to find the mean data. All right, let's execute. So 35 is basically a mean data here. So how it happened? It is just what it did. It just added all the data like 10 plus 20 plus 30 plus 40 plus 35 plus divided by how many data points? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can add it manually and try to find it. So you'll be able to get the same number. There is no deviation here. There is no difference what you are going to get. Everything will be same, right? That is basically a mean. So how I'm going to print the median then, right? Let's understand that also. So here what I'm going to do, instead of mean, I'm going to say that median, right? If I execute, you will get median is 40. So whenever it is going to find the median, one thing is to note that it will sort all this data in an ascending order, right? It will sort everything in the ascending order, and yes, and the center number is going to be the median. If there are two numbers, it is going to take an average, as I explained. All right, so that is a median. If I want to find the mode, yes, again it's the same thing. I'm just going to say mode, And if I find that mode is also 40, it is because the frequency, as we discussed. So how which number is occurring more number of times. If you look into this, 40 is occurring 1 and 2 and 3 times. 1, 2, 3. And 30, no, only one time. 50 is occurring only two times. One time and two times. All right. So what I will do, just for the sake of explaining one more time, what I will do, I will just try to increase this number 50 and one more 50. Now 50 is occurring more number of times as compared to 40. So I'm expecting 50 should be my answer. All right, as it is occurring one extra time as compared to this 40. Okay? So that is basically a mode here. All right. So you don't need to worry about